Hey all, so this is the lecture video for section 7.4, last section of our course, and after this we're officially done. So this is section 7.4. I'm recording this because if you miss lecture and if you're not in class, which I think most of you will not be, this is a very important topic, so it's better that I record this and I post it. All right. So in the previous lessons, we have learned about area bounded by a graph and the x-axis over an interval. In this lesson, we extend this idea to find the area between graphs. Now you know that integral of a function, this fancy notation going from a to b of a function f of x dx is the area between the graph and the x-axis. That's what we have seen in the previous sections. In these sections, we'll be interested in finding the area between two functions, two continuous functions over the same interval. Let's look at this one. For example, in this case, we can assume that f of x is greater than g of x in the interval, and you can see that here, right? So area between these two curves, as I'm highlighting right now, is going to be this highlighted area. So if I want to find the area between curve f and g, it's this one. But how do I do this using integrals? That's what you're going to learn today. Okay, using definite integrals, we can model the area under f like I told you. This is the area under a curve from x going from a to b, and the function is f of x. I can write this using integrals, a definite integral, a to b, f of x dx, right? And you know this, that this area is above x-axis, so my final answer, which will be a number, is gonna be a positive number greater than 0. Same thing here. I have a different function g of x, so I can write this as an integral a to b g of x dx. Again, because this is above x-axis, is gonna be greater than 0. So what happens if I combine these two functions in this graph, and now I want to find this area in the middle, highlighted. If I want to use integrals, you know what I've done? I could take the entire area all the way, okay, and subtract this part, the red part, and I would get the remaining area. But how do I write that using integrals? So I'm taking the entire area under f of x dx. I'm subtracting the area under g because that's the area we don't want, right? And using the property of integrals, I can combine these two integrals as one. This will be f of x minus g of x dx. Now, this is a pretty straightforward and intuitive concept, but you see there is one thing very important here, that the function f should be higher than the function g, right? The higher function comes first, the lower function comes after. And then you subtract them because technically you're subtracting the area under the lower curve to get the area between. If f of x is less than gx over the interval of integration, then the integral will be negative. Okay, for example, if your graph would look like this. If this was your function, this is your another function, this is g, and this is f. Okay? If f is below g and you want to find the area in the middle, but you ultimately decided that, oh, I'm not gonna do g minus f, I'm gonna do f minus g. f minus g anyways, right? This will give you a negative answer. So if you apply a negative in front of it, this will give you the correct answer. So we'll do more examples in a minute, but that's just explaining how the area between curves is represented by a function and why it matters to be sure which function is higher or lower. And I'll give you techniques on how to check. Okay, graphing the functions. So I have the first question is find the area between, now I have two functions, let me highlight them, y equals x squared, y equals x plus 4, and the interval in question, which will be the limits of your, these will be the limits of your integral. We want from 5 to 8. Graphing both on the same set of axes, we can clearly see from the graph. Now it might not be given in the exam, and we'll solve questions like that in the review also. In this case, I can clearly see that x squared is higher than x plus 4 over this 5 to 8 interval. We are only interested in 6, 7, 8, right? If I only focus on 5 to 8, x squared is greater than x plus 4. So how should I set up the integral? How do I find the area between the curves using integrals? This will be the value 5 to 8, and because x squared is higher, x squared comes first. Subtract the lower function, which is the line x plus 4, and you are, because the variable of integration is x here, you do a dx. Okay, now simplify. You are champions in solving the integral now. Let me simplify it a little bit. So I got x squared. Be careful with the negative. So negative x, negative 4, right? Dx. Apply the rules of integration. It's x squared is add 1 to the power, divide by it. Same thing here, add 1 to the power, divide by it. Same thing, constant becomes 4 times x. And then I don't add a c here because I'm looking for the area. Area should be a value, a number. So I have to solve, how do I find the upper limit, lower limit, make two big brackets. You know the drill. Make two big brackets, separate them by a negative, and in the first bracket, you replace your x by upper limit, which is 8. So everywhere I see x, I'm going to replace it with 8. Okay. And in the second bracket, and yes, some of you are asking me this question in the group work. Yes, it's always a negative. Whenever you solve a definite integral, this is the rule. You subtract the lower limit x values from the upper limit. Okay, so I'm going to do the same thing. Replace the second bracket, replace the x with the lower limit, which is 5. Minus 5 square over 2 minus 4 times 5. Now, solve this, plug this in your calculator. I have full faith in you that you can calculate this. The first bracket, simplifying, will give me this. And the second bracket, when I simplify, will give me this. When I subtract them, you should be getting, in other words, this is 97.5. So the area between the curve is 97.5 units. Square units, right? That's the value. Let's do one more example. Same thing, I'm given two functions. Y equals a quadratic here, and then the second function is a line. The lower and upper, sometimes they don't tell you. You see, the interval is not given here. The AB, like it was given in the previous question, you were given 5, 8, right? The upper and lower limits were given to you. Sometimes that's not given. So what do? You have to find this area. In this case, you make both functions equal to each other and find the intersection points. So I'm going to make the first function, which is a quadratic, equal the second function, which is linear. And I'm going to find the intersection points. So simplify, move everything to one side. What do you get? So I'm going to do minus 3x minus 3x plus 1 equals 0. This gives me x squared minus x minus 2 equals 0. And then you can factor it or use the quadratic formula. Whatever method you pick, I am okay with. You got, right? So I have got two intersection points. I've got -1 and I've got 2. All right. Now, I've got two intersection points. Take a minute, solve this on your own. It's just algebra. You have done this before. Find these two intersection points. And there is one other way that you can find the limits of the integral or these intersection points using graphs. That's what you see here, right? If I plot the two functions on the graph, I see that the intersection points, they're intersecting at -1 and at 2. And which function is lower here? The quadratic function is lower on this interval, right? And the linear function is higher. So in this case, we see that 3x minus 1 is greater than x squared plus 2x minus 3 over this interval. Now, why do I do -1 first? Because -1 is smaller and 2 is bigger. You could also test this if you did not have a calculator, if you did not have a graphing calculator on hand. You could also test this. Because I'm talking about -1 to 2, take a test point. Test point, let's say x equals 0, okay? So then you plug x equals 0 in both functions. So if I plug x equals 0 in the first function, it will be 3 times 0 minus 1, which gives me -1. If I plug it in the second function, which will be x squared, so 0 squared plus 2 times 0 minus 3, it will give me -3. And -1 is more than -3. So you can see from a test point also which function is higher, which function is lower. It's crucial that you understand this, because when you set up your integral, the higher function should come first, right? Because when you're finding the area between these two, you subtract the lower curve from the higher curve. Okay? So I'm going to set up the integral now. It will be integral -1 to 2. Take the higher curve, which is 3x minus 1, and you're subtracting the lower function, which is the quadratic. So put a bracket on it so your negative signs are not missed. And the whole thing, because the variable is dx, you get a dx at the end. Okay, simplify, see what you get. So I'm gonna get -1 to 2, 3x minus 1 minus x squared minus 2x plus 3 dx. Cancel whatever you can, and when you simplify this, you will end up with -1 to 2 negative x squared plus x plus 2 dx. All right. So now that I've simplified as much as I could, now I start applying the rules of integral. So negative x squared is just going to be -x cubed, divide by it. Same thing here, add 1 to the power, divide by it. Same thing with, well, 2 is a constant, gets multiplied by a x. There's no plus C because we are looking for the area, definite integral, right? So what are we supposed to do? Again, we are supposed to make two big brackets, separate them by a negative. In the first bracket, I replace the x with the upper limit, which is 2. So everywhere you see, be careful with the negative, okay? The negative is separate. Plus 2 times 2. In the second bracket, I replace x with, make sure you use all brackets, all parentheses when you plug in this thing in your calculator, okay? It's very important. Let me make this bracket a little bigger. So 2 times negative 1. And plug this in your calculator. Make sure you have all the parentheses, all the negatives carefully placed. Practice with your calculators. I cannot emphasize on how important this is. Put parentheses everywhere. I recommend solving one bracket first separately in your calculator. Note down the value. As you can see, I've done the value here. Put a negative in middle, right? And then separate the second bracket and then solve it separately and copy it. And then put parentheses. It will avoid a lot of unnecessary errors that you could possibly make. This is the answer. 9/2 is the area. Now if you go to the curve, the area, you'll see that some of it is under the x-axis, right? And some of it is above the x-axis, right? And the area which is under looks more than the area which is above. But the final answer we got is still positive. So maybe double check my math, okay? I could be doing something wrong. Alrighty, moving on to the next question. In business scenarios, applications now, right? For quantity like net profit, net change, and inventory or net sales, we are typically interested in the signed area. So we do not need to worry which function is above and which function is below. Let's see how it works. For example, we all know that what is revenue minus cost? It's profit, right? Suppose I started a business, teaching is not gonna give me too much profit, so I'm starting my YouTube channel business, okay? My revenue for the first month is say $100 because nobody subscribes to my channel. My cost to make videos, buy material is $200. What is my profit? My profit is revenue minus cost. At this point, I'm losing money, right? I'm losing $100, so profit is negative. So it really doesn't matter because the total net profit or loss will give me the right signs when I'm calculating it, okay? Let's see. A technology company manufactures specialized smart widgets. Their financial analysts have provided the following models, blah, blah, total revenue. Okay, there. Let X represent the number of batches of 100 smart widgets. Rate of revenue per batch. See, as soon as they give you the rate of revenue, this is R prime, okay, not the actual revenue function. And you know how you find the actual revenue function or any function for that matter? If you are given f prime for any function, okay, you integrate it. When you integrate a derivative, they kind of cancel each other out and you're left with the function itself. Same thing here. Put emphasis on this. It's important for conceptual knowledge. You know, when you're doing the MCQ true false, it's important that you understand this. So C prime means the derivative. So to find the cost function, I have to integrate it, right? So the company wants to calculate the total net profit from producing and selling the first 100 batches of smartwatch. Okay, revenue represents the R prime and C prime represents the revenue cost of each individual batch. The difference when I subtract the change, when I subtract the cost function from the revenue, gives me the profit, the rate of change of profit or loss, right? If you have any questions, you're always welcome to show up to my office hours, okay, and ask me questions. So if I integrate this, by integrating this difference, we sum up the profit contributions from each batch produced within the specific range. So let's understand this with the simple math without the frills. R prime minus C prime should give me the profit change, right? If I integrate both sides, I will get the net profit. And that's what I want in simple language. All right. So let's fill this graph. I have this graph right here. You can see my cost function is the green guy, which is the cost change, and the red function is the revenue guy. So sometimes the revenue is more, sometimes the revenue is less, cost is more. So let's see, the loss making region is where the cost is gonna be the higher than the revenue per batch. The profit making region is where the revenue is gonna be higher than the cost, higher or equal to, right? Makes sense. Profit is when you make more money than revenue. So if I start making a lot of money from my YouTube channel, my revenue is gonna be more than my cost. Loss region, clearly, as you can see here, I have a lot of loss. It's not matching the color code here because this should be red, this should be green because that's profit, right? Thus, the net accumulated profit for the first 100 batches should give me a negative value at the end, right? So let's calculate this and see if the integral gives me the right answer. You know, the integral should be set up for the first 100 batches. It should look like this: 0 to 100, revenue minus cost. Now it doesn't really matter which function is lower or higher on the entire region. We can ignore this fact. We'll apply the formula for applications part. And if it turns out to be negative, that tells me, well, I'm losing money, basically. So copy the revenue and cost function from the question. They were given to you, right? I'm going to copy these two functions here in my integral. So integral copied revenue function is 150 minus x, subtract the cost function, which is a quadratic, so put brackets on it, x squared plus x plus 20, put a big bracket on all of the things, and this is dx because the variable is x. Okay, simplify. Now it comes the, getting your hands dirty type of work. Simplify, cancel things, 150. Make sure you change the signs as you move the negative inside. So you get, when you do all the dirty work, this will be 0.05 x squared negative 2x plus 130 dx. See, so far, I'm not doing anything with the formulas of different integration. I am just simplifying. Now I apply the formulas. So the power rule for anti-differentiation is, well, it's at 1, divide by it. Same thing here. We have 2 times x squared over 2, and the constant becomes times x. And then we do 0 to the power 100. Now you know the drill. I'm going to make 2 big brackets, separate them by a negative. In the first bracket, I will replace the x with my 100, the upper limit. Okay, I'm running out of space. Well, I guess you can cancel the 2 here, right? Simplify as you go. And this will be 100 square, or plug this all in the calculator. You are champions now. You have done this so many times. And in the second bracket, I'll replace x with the lower limit, but that will make everything 0 because anything times 0 is 0. So the final answer that you should be getting approximately is negative as expected, right? 3666.67. So this is my total net profit by selling the first 100 batches. Interpretation: the total net profit from selling the first 100 batches of smart widget is approximately negative $13,666.67. The negative value, nobody talks like this. If the profit is negative, that means you are in a loss over this production range. This occurs because as the production increases, the cost to produce each additional batch eventually outweighs the revenue it generates, leading to an overall loss. So it would be a good exercise to come up with an example of such a business where producing more units is going to cost you more than earning revenue from selling those external additional units. Come up with an example. It's a fun activity. Same thing. A different question: total profit from weekly profit. Two companies compete by selling a similar product. The weekly profit for the first company is given by this little function here, and the weekly profit for the second company is given by this function. Okay, now we are comparing two companies together. Where T is in weeks, emphasis on T, which is in weeks, weekly profit is in. So there are a few buzzwords, let me highlight them. Profit is counted in thousands, time is measured in weeks. Okay, be careful in exam. When the two weekly profit functions are graphed together, we see they intersect at, well, you can see it from the graph that this is where they match, intersect at 50 and 0, right? You could also find the intersection point by making the two functions equal to each other. 0.02 t square plus 3t plus 40, and then moving everything to one side, solving the quadratic just like I did above. And at the end, when you move everything to one side, you would get this quadratic minus t equals 0. Eventually, you would get t and t minus 50 as two factors. So t would be 0 and t would be 50. So try that, just for practice. You know how to solve a quadratic equation. You know how to factor it. You know how to use the quadratic formula. Let me write the quadratic formula here in case you forgot. Right? So try to factor it, or you can just look at the graph and see that it's intersecting at 50. Now, does this mean that both companies have earned the same amount of total profit over the first 50 weeks? Well, clearly not, because the first company looks like it's lower, right? Let's check. At the 50th week, the profit for both companies is increasing at the same rate. If I were to calculate the profit at just the 50th week, P150, okay, I plug in the function for profit company first, and this would be this 3 times 50 plus 40. The answer will be 240. In other words, $240,000 per week, right? That's the unit. When I calculate the same profit for the second company, plug it there, so you get 4 times 50 plus 40. Well, this again turns out to be 240, and hence they intersect because the profit matches, right? The Y value for the 50th week is the same, which is 240 on the graph. So although they are making the same amount of money at the 50th week, But clearly, as you can see, it's very subtle, but it's there. The difference is there. If I can highlight this, you see there is a gap, right? So the profit for company 2 is higher than profit for company 1, as you can see in the graph. And that's what I'm talking about here. Since P2 is greater than P1 over the interval, we would expect the total profit over each company represented by the area under each graph will be different. To find the total difference, we need to find the area between the graphs, right? You see how it's useful to find the difference between the profits of two companies? All we have to do is find the area between the graph. So I set up the intervals 0 to 50. Because P2 is higher, P2 goes first. And you see the variable of interval is time t in weeks. So let's copy the functions from the given question. P2 was 4t plus 40 subtract 0.02 t squared plus 3t plus 4 and the whole thing dt. Now again, do the work, do the math. You cannot get away from it, I know. Simplify everything, be very careful with the brackets and everything. This turns out to be a nice question. Everything kind of cancels out eventually at the end. Okay, and now that you have simplified it until oblivion, apply the integral formulas. So you'll get 0.02 t cubed over 3, and then you'll get t squared over 2, and then you plug in 0 to 50, the integral limits. And after this, you all should be champions by now. Okay, make the two big brackets, separate them by a negative. You know what I'm about to say next. 0.02 50 cubed over 3 plus 50. I mean, just plug it in your calculator. You don't have to copy it. So the second one will just be 0. When I do the math, I'll get approximate, okay, 416.667. But keep in mind, this was in thousands of dollars. So the second company has made $416,667 more. Well, it's quite a big number for this small gap in the functions, right? But it makes a difference. That's why calculus is important. The second company has made this much more profit over the first 50 weeks. Before the CEO of company 2 gets too happy, oh my God, look at this one. What if we look at the first 100 weeks? And I guess you see what is happening here, right? The gap that the second company was being happy for, oh God, it's gonna be a big loss, right? If I check the difference now, right? What if we look at the first 100 weeks? Let's check this. Let's see. Let's do the math. So I'm gonna do 0 to 100, okay? And the function that we've already simplified, the simplified function is right here. P2 minus P1, right? Negative 0.02 t squared plus t dt. You integrate, you will get negative 0.02 t cube over 3 plus t square over 2, and you do 0 to 100 and do this math. I mean, I have faith in you. You can do this. When you do this, you'll get negative number. And you know, it tells you if this little area was $416,000, imagine how much this will be, right? So the difference is now a lot. The difference is now negative $1 million now. 1.6 million is more. This means that company 1 has now made more overall profit over the first 100 weeks by a net of $1.666667. So the motivation here is for you future business holders that do not give up, okay? It might be very possible that you are the CEO of company P1 and you might lose money by the first 50 weeks, as you can see from the graph, and your friend or your frenemy is making more money, who is the CEO of company P2, and they are just rubbing it in your face. Do not give up, because who knows, maybe after the 50-week mark you will just kill it, make a killing, and make a net profit of 1.6 million. So take this as a lesson. Do not give up in life or in math, and I'll see you in class after Thanksgiving. Take care, everyone. Happy Thanksgiving.